Alright guys, welcome back. One thing we haven't talked about so far is a path traversal attack within a content provider. And then we are done with our content providers. So we have seen an SQL injection, and now the part which is missing is a path traversal attack. So this video we will find out how to exploit this, and most importantly how to identify this type of attack in a mobile application. Are you that excited like I am right now? Then let's go. Alright, here we are back at Ubuntu VM, and I have prepared a really nice application where we can train this path traversal vulnerability. So as always, you can find this as an attachment of this section, and yeah, I have included the whole source code. So therefore, let's simply download it, import it into the Android Studio and have a look into this one. Alrighty? So I have already downloaded it, therefore I only need to start this. So I start the Android Studio, running the bash Studio SH script. Here we go. Alright, here we've got the welcome screen. And let's see, to import this project, all we need to do is simply clicking on import project. And then we are selecting this amazing music player APK. So let's do this. Okay, let's finish. Oh, it's already finished. Nice. No tip of the day. Okay. So the first thing I like to do when analyzing a mobile application is having a look in the manifest, because there we get a good overview what's going on. So let's do this. Android manifest, and here we have it. So we can see we are using a permission, read external storage. Alright, this is something we have to look for. Then we've got our application tag, nothing too fancy in here, and then we've got a provider. So here we've got the content provider, and this one is being defined in this class. Alright. Here we've got the authority name, enable true, exported true. Alright, so this content provider has been exported true. So this content provider is available to the outside world, which means we can interact with this one based on another application or within the ADB shell. Alright? We do not know right now if we are interacting with a database or with some files. We will find this out by analyzing the code inside this Java class. But for now, let's keep it this way. So we know we've got a content provider and it's being exported. Okay. Then we've got an activity, our main activity, our well-known intent filter. So this is our entry point. It's listening for our click on the icon to get started. And then we end up there. All right, so far so good. Before we analyze this code further, I would suggest let's have a look into this application, because I've got a feeling that this one, it's a really amazing one. So let's see. Here we've got our emulator. I have already started it, and to install this application all we need to do is hitting this fancy run app button over there. Let's do this. And let's keep this over here. Okay, the Gradle build is now running in the background. Afterwards the application will be built and transferred to the smartphone via ADB and automatically being started. So all of this happens magically in the background, and there we go. Does this look absolutely amazing? Yes. No, it doesn't? Okay, but let's see if the functionality is given, because I mean that's the most important point, right? So let's turn up the volume. Oh, already max volume. So let's see. We've got a music player and we've got a play and stop button. So let's see. Cannot hear anything. Now. Yes. This is absolutely chilling, relaxing music. Ideal for attacking applications based on a path traversal vulnerability. Absolutely amazing. So I really want to thank the author or the musician, I would say, for this track, because it's being provided under a license which can be used in courses like this. So here are the credits for the author. Really thank you. Alright, back to this one. So we've got a really nice music player, and I've got also a little feature in there. But first let's see if the stop functionality works. Yes, music is stopped. Okay. So now we've got some kind of mixing application, because if we hit the play button, then this relaxing music starts once again. And now we can play it multiple times. For example, I need to hit the timing. Okay, completely missed it, doesn't matter. Let's keep doing it. Okay, sounds absolutely horrible. And the stop doesn't work. Amazing. So let's close this real quick. Alright, so Yes, I have prepared it, of course, in this way that we can do this to make it a little bit more interesting. So now you've got a music application, and if you become once a great DJ, then please give me some credits back on this video over here. Alrighty? Perfect. Okay. So for now we know what this application is doing, at least, yeah, the main purpose. But let's figure out what's exactly doing. Okay. And therefore I would suggest let's go into the main activity, because this is our entry point. So main activity. And let's see, so we've gotten context, media player. I mean, we haven't talked about this one, but we can guess what this one is doing. Our onCreate method, text view, context, nothing too fancy. Oh, what's this? Create secret file. This sounds interesting. Let's see. Here we've got start and stop music. Okay, this might be those functions connected to the button. And yes, you can see this is not a programming mistake. I did this on purpose. All right. Okay, I mean, okay, the stop function, this is something I have messed up, but yeah, that's okay. So back to this one, we've gotten create secret file. So what is this doing? We've got two strings. This might be the file name and this the content, okay. Then we've gotten file output stream. I mean, we do not know what this one is doing, but hey, okay, we've got an open file output. So, whoops, let's get this out of the way. So maybe we are opening this file, my secret file name over here, in the context private mode. And then it seems like we are writing this content to this file. So we are simply creating a file. And the amazing thing right now is this file is being stored in the protected data directory of this application. So this is within the sandbox, like the shared preferences, for example, which means a normal user cannot access it. Right? Let's verify this. So let's make our ADB shell connection. And then let's see, we have to get root privileges. We will test it afterwards without. So then we have to go into data, then the package name. What's the package name? Let's see. Let's keep this in foreground. This is the package name. Okay. And then we've got directories, cache, code, and files. So let's go into files. And here we have my secret file. Yes, let's check the permissions of this file. Okay, this user or higher privileged users are able to access this file. All right, let's print it out. Is there something in there? Yes, this is my super secret text that no one should read. All right, I mean, this text has been included in the Java source code, so at least after talking about reverse engineering an application, we would be able to read this. But let's say it stores some user credentials. So there might be some initial credentials, okay, but afterwards the user provides a new password and the password gets updated in this file. Then we are not able to fetch this information based on the source code. All right? Okay, so now we need to make sure that really only this user or higher privileged one can access this. Therefore, we leave the root context and we're printing it out, printing it out once again. Let's see. Permission denied. Perfect. So this is exactly like it should work. We've got a file, context mode private. It's being stored in the internal sandbox app directory and no one else. Okay, this application in higher privilege can read this, but no third-party apps right now. Okay. All right. So this is the whole functionality of this main activity. It's creating a file and it has two buttons. So the interesting part right now is there's absolutely no other interaction. So we do not access our content provider in there, which raises the question, do we still have a vulnerability? I mean, we are not using this code. But before we talk about this, let's first have a look into this content provider. So here we've got the music file provider class. And this one is extending this content provider. And here we have now the methods. Most of them are not being implemented. So there are those to-dos, please implement this stuff. We've gotten delete, get type, insert, on create, query, and some other stuff. Yes, update. This looks like our database interaction, but it seems like we're not having a database interaction. But what we have is this parcel file descriptor, whatever this means, open file. So this one is also an overridden method, which means this one has been defined in this content provider. So now we are not dealing with a database anymore, we are dealing with file access. Content provider means providing content beside databases, we can also provide access to a file. Amazing, right? Absolutely. And here we can see we've got this open file. This one is now taking two arguments, an URI and a mode. The URI seems to be the file path because we can see we're creating a new file object based on this URI. And then let's see, is this being used? Over here. This one is being used here, and we are opening this file right now, and we can see this mode. I mean, it might be read, write, append. Not sure if append exists, but this mode is simply what type of access we want to have to this file, read or write. In this case, whatever we provide in this open file method, which is, by the way, exported to the outside world, so we can interact with this one, we can provide those two parameters. But this parameter, at least this mode parameter, is not being used. Even if we say we want to write to this file, it's not working because we've got it hard-coded over here in read only. Okay. But let's do it not that quick right now. So here we are opening this file, okay, and it's being read only, and then we are returning back this Pathel file descriptor. So this one is simply just a descriptor to this file. So it's some kind of, let's call it access to this file. I do not want to go too deep into the Linux system right now because it's not relevant. So we've got file descriptor and sockets, but at the end, I mean, what this means is we are getting access to a file. So we can interact with a file, and this file we can interact with is being opened over here, and it's being referenced via this URI. Okay? So we provide a file we want to open to this content provider, and this content provider is opening this file and providing us access to it. Okay, a use case could be, for example, sending a music file to this type of application. The content provider is opening it, and within the return function over here, it could also now put this into a music stream and start playing it, for example. But to make this as simple as possible, I have included only the necessary parts, so the bare minimum to make this content provider working and vulnerable to our type of attack. I mean, if we find now this use case, an exported content provider with this parcel file descriptor open file URI, and this URI is directly passed into a file which is being opened over here, then we've got our vulnerability. You do not see right now which one? No problem. We will discuss this extensively right now. All right? Okay, so therefore, let's get on the graphic tablet and let's see. I make a little bit of space, and now let's directly write this over here. Okay, so let's see. We've got our application. This one. This is our music player. Let's make this green. And this one is now exporting this music file provider, which is a content provider, and this one is exported, which means this method is available from the outside world. Okay, so we can interact with this method. This method is now taking two parameters, an URI and mode. So the first question is, what is this URI? The URI is simply just a reference to a file, and it looks like the following. So if you want to reference a file, we can do this in the following way. Content, this is our scheme. Then we've got the authority name. I just named this AN right now. And then we've got the file name. So in case if you want to open, for example, something on the SD card, I guess it looks like the following. Content / our authority name, and then SD card music.mp3. To access this file, it's based on the SD card. I mean, we have to use this read external storage permission, but this app has this permission, so this would be fine. All right? Okay. So now's the question, how can we exploit this? Well, if we're now having this application, our third-party application, our malicious attacking app, then we can now provide a file which this application is going to be open, in this one over here. And instead of using the MP3 file from the SD card, we can provide, let's say whatever we like. But of course, this app needs to have the permission to open this. Okay? So what if we are not providing the SD card MP3 file? What if we are providing something like content / then our authority name, and then access to this my secret file. My secret file. Then this application is taking this URI, it's assigning this to a new file, it's opening this file, and it's providing back an access to this file within this parcel file descriptor. So we send this to this application, and this application is now turning back this file descriptor, this parcel file descriptor. Let's say it's simply access to this file. And now there's this clue, because the my secret file, this one over here, it's an underscore, nothing else. So okay, let's clean this. There we go. So now we've got an underscore. This my secret file is being stored in the data directory of this application. So this one, let's take another color. Oh, that's not visible. Let's take this one. So this one has in storage in our smartphone, data, and then the package name. And then we've got files. And then we've got my secret file. So this one is being stored in the protected data directory of this package. Which means if our application tries to access this file, we have seen this in the ADB shell with cut, access is being blocked because this user ID has not access to access this file, has no permission to access this file. All right. But now, if we ask this application, so we are asking, let's draw this once again to make this more dramatic. We are asking this application over here to open this file via this method. Then what's happening is this application has access to this file because it's being stored in this internal directory, and this user ID, of course, has access to open this file. And now this application is opening this file and providing back access to this for our application. So this one here will be now provided back an access based on this parcel file descriptor. All right. Okay. If not, don't worry. We will discuss this now once again regarding to the type of attack, and then we will do some practical exercises regarding to this one. All right. Okay, so here we've got this application and here we've got our application. So now we know we can interact with this content provider and we want to send a file access request. And for example, this open file here. All right, so we can define the URI. And now to exploit this path traversal vulnerability, we have to do it in the following way. I mean, we've got multiple options, but I show you one option right now that works all the time. And therefore you only need to remember this one and not the other parts, all right? Okay, so the problem right now is if you want to open this file, this my secret file, so we would have to provide the following path, content / then our authority name, and then files, and then my secret file. We do not know the context of our file access. So this URI here might prepend some additional stuff. For example, it could say instead of accessing or passing this URI directly to our application, it could append another directory first. In our application, we've got 3 directories so far. We've got cache, we've got something else I do not remember anymore, and we've got this files directory. Okay. Now let's say this application code has been designed that this one is the base directory. And if we now append this part, the application tries to access this files directory in this cache directory. And within there, this my secret file, which is of course not available. Because this my secret file is being stored over here. So we are now opening or trying to open a file in the cache directory, but this file doesn't exist because we are within the cache context over here. Yeah, let's call it context. So the application starts opening a file under this directory. So on the first view, it seems like we cannot access any other files beside those files in this cache directory, right? No, of course not. Because what we are doing right now is a path traversal attack, which means instead of providing files MySecret file, what we can do if we are in this cache directory context, we could simply append in between those two. Oh, it's getting a little bit messy, but I guess it's okay. // Okay, it's too messy. Let's rewrite this. What this // is doing, if we are now in this cache context over here, we are getting back one directory. So we are going back one directory, which means we are now in the root directory of this application. Okay? And now we are entering the files directory. And this is now available because the files is over here. And now we have left this cache context. We are now in the files and we can open this MySecret file over here. So this would work just by providing a // Now we do not know in which context we are, and to provide you a solution that works all the time, what we can do is providing many // attempts, which means we want to go back to a state where we know how the structure looks like. And the state, how far we want to go back, is the root directory. So if we are in the root directory of the smartphone, then we know we've gotten data directory. This one has another data directory. This one has now this package directory, so the package name. And this one right now has this files directory. And in there we've got this MySecret file. So if we go back, or if we have the ability to go back to the root directory, then we can always apply this scheme, because this never changes based on the root directory. All right? Okay, so how many // do we need to go back to the root directory? The answer is we do not know this, because we could be in this directory, or we could be in a subdirectory, or even further. But that's not a problem, because once we have reached the root directory, we cannot go further back behind this root directory, because that's the starting point. So we cannot go further back, which means we can apply as many // as we want. We just need to have enough to get out of every single subdirectory where we might be in right now to go back to the root index, and then we can follow along our path over here, this one. So this is how a path traversal attack can be easily exploited without having to worry about where we are right now, what's the structure, do I have to go one directory back or forward, and things like this. Alrighty? Okay, so therefore I would suggest let's simply do this. Let's try this out. So our attacking vector, let's clean this up a little bit. Okay, so our attacking vector would be something like this. Content // then the authority name, and then // and so on. Another one, just one for good luck, this one, and last one. Okay, this is really the last one. And then we append our files, and then this MySecret file. All right, this is the content we are providing from our application to this application, and nicely asking, hey, please open your secret file for us and provide us access to this. You might ask right now, why is someone developing something like this? But there are tons of really good use cases to do this. I mean, not in this way, of course. The mitigation would be simply filtering this part over here, this URI. But if this is not being filtered and we can directly provide our parameter into this one, then we can access those private files. And this happens quite often still nowadays. There were a couple of really, really insecure path traversals that lead to huge security risks of those applications. I mean, imagine how many sensitive data are being stored in the shared preferences or databases or things like this. We can access all of them if we're having this type of vulnerability. Amazing, right? So therefore, let's do this. How can we send this file right now? And once again, we do this in the ADB shell, and then we write our own custom application to perform this task. You ready for this? Then let's go. Okay, so first let's clean this up. All right, and let's also get this a little bit further, that we've got access to those things. Okay, and I would suggest let's open this application in the background. I mean, is it required to be open? I'm not sure. I guess not. we can try this out later on. But I really like this chill out music, and yeah, I guess we can play it because it's license free. So therefore, let's play this music in the background. All right. So now we've got some relaxing music to exploit this right now. Okay. Limit volume down. Okay, cool. So if we want to interact with this content provider, we need our ADB shell first. And then what we need to use is content. And if you remember, okay, I'm not sure if you can still hear it, but for me it's fine right now. Okay, maybe one volume up. There we go. This should be absolutely perfect. So yes, here we've got our content provider help, and we have talked about this, that we have split it into two paths. I guess we did split it over here, but this one might be, I'm not sure. This one might be, yeah, I guess we should split it up this way. This is file related, and this one here is database related, this help path. Okay. So this means we can focus on this one. And I mean, we've got ADB shell content read URI. Well, is it that easy? Let's find out. We've got read URI, write URI, and get type. I guess this is regarding to meta types. Not sure about this one, but yes. So I would suggest, let's see. Let's clean this up. Okay, if we now want to open a file, so I mean, what we have to do is content, read, and providing the URI. All right, what is the URI? Well, it starts with content, so that the content provider knows, okay, this is regarding to the content provider, or this application knows this is regarding to the exported content provider. And to say that it is for exactly this one, we have to provide the authority name, this one. Okay, and then we have to provide the file we want to open. So we have seen our my secret file was under files, my secret file. I guess this will work because we start maybe at the application directory. So let's see. No, okay, it doesn't work, which is good, which means we are not sure in which context we are right now. So therefore, we didn't hit this file. But we know the file structure behind this. So let's go back to the root directory and then follow along our path. All right. So to do this, yes, let's first make sure that we are hitting the root directory. So we are applying lots of dot slashes. It doesn't matter the amount. It just needs to be enough to get back to the root directory. So it could be 3 or it could be 15. We have to try this out. But we cannot make too much right now. So therefore, let's add some additional ones. Okay, so now let's open another shell and let's verify this. So we are getting root privileges. Now we are hitting the root directory, and then we're following along this path. So data, and now this package name, com app hacking music player. Then we've got files. And here we've got my secret file. So this one is the path from the root directory. Okay, and then we just need to open this my secret file. All right, let's see if this works. I hit this in 3, 2, 1. Yes, this is my super secret text that no one should read. Is there a typo? No, okay, perfect. I mean, this is how we can access arbitrary files in this application. Amazing, right? So yeah, I mean, this is how to exploit an path traversal vulnerability. The things we have to look for is, let's see, let's play it once again. Because it worked absolutely smooth based on this one. So the things we have to look for is a provider, which is exported to true and which has this method be defined. This parcel file descriptor open file, and this URI is not being filtered. If this is the case, exported content provider, open file, unfiltered URI, then we've got a path traversal vulnerability. Amazing, right? So let's see how we can exploit this from our own application. Because I mean, having this in an ADB shell, it's well enough to show this application is vulnerable to this type of attack, and you do not need a further proof. But in case if you have customers, then it would be absolutely amazing showing secrets, passwords, databases in your application, right? Absolutely. I mean, we also do not have to get physical access because we can do this remotely with HTTPS requests and things like this. But I guess an and demonstration app where it opens those files in our own application. This should be well enough. All right, let's do this. I'm super excited about this. Oh, okay, still super excited because the code is not really much. So this just takes a few minutes. For me, maybe many minutes, but I do not want to extend this unnecessarily long. Okay, so let's create let's create a new project. Okay, we choose empty activity. And then we name this, how do we name this? PathTraversal POC. Yes, I choose language Java, minimum SDK this one. I click finish. Turn down the volume a little bit. It's way getting too excited right now. All right, the build process has been finished. Here we've got our onCreate method. So how can we now perform the same task in this one? Not this one. This one. This one. So, no, this one also not. I hope I've got it still somewhere opened. Okay, then let's do this real quick. So ADB shell, content read, URI content, and I've got it maybe in the clipboard. Yes, looks good. There's 1/ too much. All right. Yes, okay, this is working, perfect. So this is the file, or this is the content request, this URI request we want to send to this application. Okay, so how can we do this? Well, once again, we have to define our content resolver, and we can do this with the get content resolver. And then we've got an open input stream. Yes, so this one is asking for an URI. Okay, therefore let's define this URI, and we have already seen this, how we can do this. So URI, new URI object, and then URI.pass, and this. Yes, okay. What's this one returning? Let's see. Okay, it needs to be surrounded with try and catch because file access can go wrong. And what is this one returning? Can we see this? Okay, then I do it this way. Then we get an error because what's the return value? Input stream. Okay, so this one is returning an input stream. Input stream. Okay, let's name it in this way. And yes, this is already doing all the magic. So we are asking by this get content resolver open input stream, we want to have a stream to this URI, and we are passing now our PathTraversal attack to this application, which gives us back a stream to this file. All right? Okay. So now's the question, how can we print this out? And to be honest, wow, this is very deep in the Android programming. I tried to show this on a high level and then explain how we can print this out. All right, so just on a high level, and we do not go deep into this one. So let's get back on the graphic tablet. Okay, so to print out an input stream, let's see what's happening. So we've got our file, and this one is now returning back this part here. This is our input stream to this file. And this one is of course not simply just a string because it's some kind of stream. So we need to fetch data from this stream. Okay, what we need to do is we need to do the following. I guess I'm also not 100% sure. Let's say we are filtering this, or we are accessing this based on an input reader. So we need an input reader in front of this. Okay, then we've got here a reader which can read the stuff which is going from the input stream to us. So in this direction, this is our app here. And this one is the other application, which is providing this stuff. Okay. And then in the input reader, I guess it's a buffer reader. In case it's not this, or is it read buffer? Buffer reader, read buffer, read buffer. Maybe it's this way, read buffer. Otherwise, we will look this up. And this one can now read certain parts out of the stream. For example, 1024 bytes all the time. And those bytes can then be transferred into a string. And we can append our string. and we need to keep reading from this stream until we are not getting any data anymore. So if these are our data, until the stream is not returning anything, then we know we are at the end right now. All right. Yes, this sounds absolutely complex, but I guess these are just 2 or 3 lines and a while loop. But we will find this out right now. So let's see. By the way, yes, this is not an app development course. So in case if this is now too much for you, lean back, relax, turn up the volume of the music, and then just watch me doing this. In case if you want to have a reference application, so in case if you want to show a customer, hey, this is how we can exploit this PathTraversal vulnerability and show the data in our own application, simply copy paste this code when it works. So if it works, then you can freely use this, of course, and you do not have to go through this, or let's say even understand it completely. But it's good if you have an basic knowledge about this. All right? Okay. So here we've got now our input stream, which means we now need our input stream reader. We need someone who understands what's going back. Input stream reader. And this one, let's see. We can, I guess, supply this part. Yes, this input stream has been defined in this try and catch block, which means if we are getting an exception over here, this variable is unknown for this part. Cannot resolve the symbol. Exactly. Which means we simply create a variable over here. Then this application is aware of this, and we make sure with our try and catch block that everything works fine before. Okay, now we've got the input stream reader. Now we need to read the stuff. And we need to keep reading until we are not receiving any data anymore. And this can be done within a while loop. So while, that's a good beginning. But now's the question, we need this condition when we are not receiving any data more. And I guess this is being done with buffer reader. Let's see. Oh, this is read buffer. Read buffer reader. Buffer reader, this way. Buffered reader. Sorry, now we've got it. Okay, but we need to assign this buffered reader first. And we can do this over here. So we are creating a new object, buffer reader. This new buffer reader. Whoops. So we are now reading from this input stream reader our single buffers. Okay, and now we've got this condition, buffer reader and ready. Yes. Ready sounds a little bit misleading, but this also means if it can be used as a condition if you're not receiving any data anymore. And it's also making sure that we can access further data. So our reading might be blocked during the read, but let's do not go too deep into this. So this is our condition. And we've got an error over here. Let's see. Surrounded with try and catch. Whoa, okay. I'm not sure if I like this code right now. So we've gotten while true and we exit out. Well, no. Let's make this different. So, whoa, okay. Let's get this try block over here. And then let's take our buffer reader as a condition. And let's see. Okay, there's this. Here we've got our try. Oh, there's this bracket missing. Yes, okay, now it's good. So, I mean, I'm not an encoder, but even this part was, no, this was nothing I would like to go for. Okay, so now we are reading our stuff with this buffer reader, and we can assign this now to our string. So we are defining a new string. This is the file input. Okay. I also do not like this way. Okay. So now we can use this file input plus equal and now buffer reader read line. Yes. Okay. So now we are reading one line out of our file and we are assigning it to our string, to our file input string. But the problem is right now, this read line ends at the new line character. And if we are reading this line, it will append everything in one line right now. So if our file has 10 lines, our string over here will have everything concatenated together right now, which is not really readable. So therefore, after this read line, we are appending a new line, because then we know the line has been ended. Is this so far okay? So in case if we're having 10 lines, our string would put everything into one line. But after reading one line right now out of our 10 lines, we are appending a new line in our string, which means our string gets also split up, that we've got this nice format. Yes, and this is everything we need to do. Yes. Okay, I mean printing it out, system out print line. And then we are good to go. What's the problem? System out print. I'm out of this function maybe? Oh yes, I'm out of this function, sorry. Okay, we need to put that over here. All right. Now we're good to go. Okay, the only thing we are missing right now is if you want to use this code on modern smartphones, on Android 11 and higher, because then we have to deal with those privacy settings, which means even if this content provider is being exported, we are not able to interact with this until this application is visible for us. We as an attacker, we do not care about this, because of course we want to be visible for it to fetch all the data. I mean, we do not have any problems with this. The application might, but in our application, everything is fine, all right? So therefore we go into the manifest and then queries. Ooh, let's see, not sure. Package, and then, there it is, Android name. Hui. This, I wouldn't remember this, and we could simply look this up, but having it in this way is better. So we need to have this package name, this one. And that's all. This should work right now. So our application should be able to fetch the secret file out of the other one. Let's see. So let's run this. And then we test if the application has to be in foreground, because I'm really not sure about this one. This will be interesting also for me. Okay, so our application starts in just a moment. Buckle up. There, I can already see it. I have seen it. System out. This is my super secret text that no one should be read. Amazing, right? So this is within our own application, the PathTraversal vulnerability. And you know what? Let's print this text out over here, okay? So let's print it out directly on the screen and let's apply our hackish scheme. I mean, this is absolutely not relevant anymore, and you can, feel free to skip this right now. But I would suggest we do this real quick. It just takes a few minutes. Okay, so what we need to do is we need to go into our activity main XML layout within code. And then, I mean, we've got this hello world text view. So let's make a default text hacking in progress. Okay. Then let's make the whole background black, that it looks absolutely zero hexolete. So Android background, color black. Okay. And let's make this text kind of green. I mean, it's not even close being green, but I do not know the English term for this one. So let's make this teal. I'm not sure. Okay. And maybe adjusting the size. 14 dp, and also let's put it a little bit away from the left, that it's not fitting directly at the screen. So let's apply a padding of 20 dp. I'm not sure if this is too much. Let's see. For this text it's okay, but let's see how it works. Okay. So then we need an ID for our text view to address this in our main activity. So we need to assign a new ID, add plus ID, and we name this simply text view, like always. Okay. And then this is all we need to do. We have assigned an ID. We made this absolutely looking hackish. And the only thing we need to do right now is going into the main activity and assign this one. Okay. So over here we are creating a new text view. So we are having a text view in our application, and now we are assigning this text view. So this text view, I keep this typecasting even if it's not common anymore. So that's the way I'm doing this. Okay. So now we need to find this ID and assign this text view, which has been defined in our layout, which is available in the onCreate method, to this text view. And this is easy. Find view by ID, r.id. And then this name. Okay, and then instead of system out, we are simply setting this text of this view. Set text, and we are done. That's all. Let's run this and let's see what amazing hackers we are. This is the wrong. Okay, there we go. Oh, this action bar. This is my super secret text that no one should read. All right, amazing, right? I mean, we can also append accessing my secret file. And then we can make it a little bit ugly, but I mean, it's okay. So let's get also rid of this action bar because this is looking awful. This can be done in the theme, in the Android manifest theme. So there we go into theme and then design our action bar. I mean, there's also in dark, I guess. Okay, but let's simply stick to this one. Let's see. Okay, our app is being loaded and there we have it. Okay, it could be a little bit more pretty, but I mean, as a demonstration, it's enough, right? So we can see within our application, we are accessing this file. And the thing I really would like to test, if this is working, if the app has not been opened. To be honest, I guess it is, because within our intent filter, we did get this error message that running in background task is not allowed, but this seems like not to be in background task. So let's see. Oh, I really need to apply some icons, otherwise it's getting a little bit annoying. This one, PathTraversal. So this app has been closed. Let's see. Is it still working? Finger crossed. Amazing. It is still working. So we can access this file anytime, as often as we want. Is this cool? It's absolutely nice. Alrighty, so this is all for this video. Once again, it did become a little bit long, but yes, I mean, the things we have seen over here are pretty amazing. And this is something which still works also in bug bounty programs. Because this type of attack, it's absolutely critical, and many people do not look for those type of vulnerabilities in mobile applications. So if you want to do some bug bounty program on this one, also have a look at the reversing section. There we will talk about mass decompiling applications, and then I hope you earn a lot of money. Alrighty? Okay, so next we have some practical exercise. So the Thief application has exactly this type of vulnerability in there. And this is something you can practice on your own if you like to. So the task would be try to identify the PathTraversal vulnerability and try to exploit this. I mean, I'm not sure. Yes, so for example, the shared preferences should be readable. I'm not sure what type of output we get if we want to try to access this database. But to be honest, I think this should also work. It might look a little bit gibberish, but yeah, the text should be there, okay? So try to exploit this in the Thief application to get back the passwords or the database. Alrighty? So good luck and have fun.